So thank you for giving me the opportunity to share with you some thoughts this morning. Thank you for the introduction, Haley. So this morning I want to share with you a little bit cover cropping and green manuring to improve soil and plant health in the context of running an organic biodynamic vegetable farm. And I kind of want to reflect on some of the things that worked and some of the things that didn't. Sometimes what didn't work is just as important as the things that did work. What I'm going to be sharing with you is not really scientific, it's anecdotal. And so even when you come to the description of what is healthy soil, I do that through observation. And here's a picture of some clover roots that were dug up. And you can see that the hair roots are completely immersed and attached to soil particles. And in German, we call that Wurzelhosen. Root trousers. I am told that in English that would call root braids. But what a wonderful indication of a healthy soil when you dig up the ground and you know that there's an incredible intimate relationship there between the root hairs and the soil. And we also know that one way in which we compromise that integrity between the plants and the soil is through plowing. Here a picture of the prairies about 100 years ago, where we know that over the course of 100 years, we completely depleted the organic matter levels from like 15% when the colonists found it to about 5% nowadays. Here's a graph that shows you, it's out of my old textbook of soil science of my agriculture school, where here's a hayfield. And over 25 or plus years, the organic matter levels went from about 2.5 to 3.2. And in less than 10 years, it just goes right back down again. So we do know that cropland really is not able by itself to maintain organic matter levels and therefore soil health. Now in weed control science, we talk about using many little hammers. And I would not want to use that same analogy here for maintaining soil health and plant health. But we are using many different approaches. There's not just one single approach that works in order to obtain soil health. Crop rotation, multi-species cover crops, green manures, mulching, reduced tillage, all in the context of nutrient management, is really the approach to where both soil health and plant health can meet in a way that we are achieving our objectives. Now, very early on in my career, I was very inspired by Eric and Ann Ordell, who took the very old principle of rotation called COW, C-O-W, corn, oats, and wheat, and applied that to vegetables, initially to obtain really good weed control. But what they also were finding is that they were, through that principle of what they call incorporating neutral years, whereby cover crop and green manure years are alternated with cash crop years, they were able to maintain or even increase their organic matter levels. And I think neutral years in general is something that is a very good principle to adopt as a vegetable farmer, because you can allow your markets to dictate your crop plan. And the labor savings in weeding and harvesting often offset the cost of taking land out of production. But since Eric and Ann Ordell, they're working in the context of a horse-powered farm. They were working with mostly rye and vetch and oats and peas as cover crops. Later incorporated some things like cowpeas, but mostly succulent cover crops. I was looking at being able to get a lot of biomass and being able to plow that under, especially since the soils I was working with were quite hungry. They really needed a lot of organic matter. And I dug up this book by Adrian J. Peters, who did a lot of research in the 30s. And this book is being published still under the title Green Manuring, Principle and Practice. And I got introduced to that book with all kinds of cover crops and green manures that I had never even heard about, like Crotalaria. So I started working with legumes like Crotalaria that are quite tall, that can compete with some of my tall grasses. because one of the first principles that in this rotation we always followed was to have a multi-species. And the multi-species mean with that always a cereal and a legume combined, because the two really egg each other on. And if you want to get a lot of biomass and you want nitrogen fixation in your soil, we always try to get in this rotation a combination of a legume and a cereal. So this is a rotation whereby in actually 4 years, instead of having a neutral year, we were able to get 3 cash crops out of 4 seasons. And within this particular rotation, we were still able to maintain organic matter levels by plowing under a very large amount of biomass. And it still was in between some of these cover crops and green manures, there were still some possibilities for fallowing in order to do proper weed control. So let me just walk through this a little bit with pictures. Now, the farm, Roxbury Farm, that I will be sharing some pictures about right now, we're at Filia, which is a much smaller farm, which is no longer in the context of animal husbandry. When you have the advantage of having a vegetable farm with animal husbandry, you have access to all that wonderful large equipment like a hay binder. This is a disc bind. So we would let the rye grow up till antithesis, which is when it goes into flowering, and then cut it and turn it into rye straw. And the rye straw was for the bedding for the animals, but we also used it for weed control in between black plastic. Here it is in onions. Onions a little later, and that worked quite well. And this is allowed me to, during a cash crop year, to reduce the tillage in that particular crop. You open up the ground in the spring, lay your plastic, plant onions, lay down straw, and then the ground was untouched after that and not exposed. Another wonderful side effect between some of the other crops like melons and cucumbers and peppers and tomatoes was that these crops remained clean. For us, that meant that we no longer had to wash these vegetables. And that is always a good thing within the context of food safety. All right, let's get back to the rye. So the rye is harvested. So imagine the stubble being out there in the field, and the ground is usually quite dry. We're talking here about the end of June, beginning of July. And we have a Great Plains no-till grain drill. But I'd have a hard time actually sometimes penetrating that very hard surface compaction of the rye. So, and also we actually use that as a huge opportunity to, apologies for the dog. We use that as an opportunity to, if we had a plow pan, to subsoil. And this is a yeoman subsoiler. And by going 1 or 2 inches below the plow pan, we were shattering that and avoiding compaction. And being able to do that at the time of the year when the ground is dry, it's much more effective. And that is usually right after we harvest the rye. Now, there might be times when the ground was so dry and so hard that we also had to chisel plow in order to plant our sorghum and crotalaria, and in this case, we even mix in some cowpeas to get that planted. That mix didn't work very well for a number of reasons, so we actually went to crotalaria and sunflowers and sorghum. The whole thing is about these crotalaria was that it took a long time to establish, and you could have quite a bit of weed pressure. So we needed to look for something that would cover the ground a little bit earlier. And first we used the cowpeas for that, but that wasn't as successful either. And the Japanese millet, the problem with that is that it would go to seed, creating actually a weed in the following year. So the sorghum being maturing a little bit later has not provided that problem really yet. But you also have to choose a variety that is not as aggressive, not as tall, because you can, of course, have that issue whereby the crotalaria can be completely overshadowed, and therefore you can really use much more than 20 pounds of sorghum mix. We went to a lot of different mixes before we found that this particular mix of 65 and 20 worked quite well. The sorghum actually dies down a little bit in the fall, and then the crotalaria comes in as gangbusters. So that's when, this is about September, and that's when a lot of inoculation happens by the crotalaria in the soil. Now, you can ask yourself the question, how am I going to get rid of this? This is a lot of biomass. So yes, that is an issue. And hence, this is not being practiced on a horse-powered farm. But if you have access to a neighboring dairy farmer and you're willing to pay them what it costs them to run a machine like this by the acre or by the hour, this is a great way in order to be able to reduce all that biomass into very small particles that are easy to incorporate. Now, unfortunately, dairy farming is hard, and this particular dairy farmer had to sell his farm and also his chopper. So we had to come up with some other solutions. And mowing that material while it is still green will break your mower. It's not a good idea. So what is the solution that we came with that is that we wait until after the frost. And the frost dried out the sorghum and crotalaria to such extent that a November mowing was so much easier on the equipment. Now, what that meant too is that suddenly we were no longer trying to incorporate this. So it was sitting on the surface. So all that wonderful green material first was, reduced in some of the nitrogen content by the frost, and then of course exposed to the elements over the winter. But we still felt that this was a really good thing. So instead of incorporating in the fall and following it, say, with oats and peas, we were letting it sit like that over the winter. This is what it would look like after the winter, a very heavy layer of mulch that protected the soil, and where, because of the aggressiveness of both the sorghum, the sunflowers, and the crotalaria, there were no weeds underneath. This is not a slide whereby the crotalaria is drilled with oats and peas, but that's the idea. That's the drill, just to have an idea of the drill that we were using. And then the oats and peas came up directly through that mulch. One of the things is that we were not trying to get rid of all that mulch in the spring. It would take a tremendous number of passes, and we didn't think that was really a good idea. Mostly what it needed was a lot of nitrogen to break that stuff down and let the soil microorganism do that for us. So by having this cover of oats and peas that grew up like that, what we're finding then is that over the course of those couple of months in this crop, there was literally no mulch left of the crotalaria and sorghum. It was all being pulled down by the earthworms and other microorganisms. And it is relatively easy to get rid of a standing crop of succulent oats and peas by the beginning and the middle of June. This is the quotation whereby we would apply some amendments in the fall on top of the compost, on top of the crotalaria and sorghum, if the soil test showed us that we were low on potassium or other nutrients. But otherwise, the following crop, which is cabbage or broccoli or cauliflower, was completely dependent on the nitrogen input from the oats and peas and the remnants of the crotalaria. And we did some research with Laurie Drinkwater, and there was one year where the oats and peas were fixing 200 pounds of nitrogen. More than sufficient to be able to get a very prolific crop of both broccoli and cabbage and cauliflower. And the other thing about the oats and peas is that the tillage practices were not as complicated because of the fact that we're trying to work under a succulent crop. In the following year, the rotation, we would not have a cover crop after the broccoli and cauliflower and cabbage. Will be followed by sweet corn that would have after a spring fallow. Now the sweet corn will be mature relatively early in the season, enough time for us to plant oats and peas before September 1st. And that oats and peas would get actually quite tall. And that also demanded a mowing as well, just like the crotalaria. So by the beginning of November, we would not just be mowing the crotalaria, we would also be mowing the very tall oats and peas. And that's what it would look like the following year then. That was relatively easy to incorporate, and then followed by potatoes. And the potatoes will then be followed by rye. Now we practiced these rotations for a number of years, and the plowdown of cover crops had increased the organic matter levels from about 2.4 to 3.5%. And we were pretty proud of it, but we did hit a ceiling. Now on the biodynamic farm, you strive to reduce the total inputs to balance soil and plant health. So increasing this even more above 3.5 was just not an option. Just a little bit about biodynamics. It's based on the fundamental principle of integrity, that everything in nature is interdependent, and that the farm is a living organism. So here, this quote, I was wondering if my understanding of this should not only be understood from the perspective of inputs, but also from the perspective of losses. Now, just a little footnote here about Steiner is that if anybody wants to pick up the agriculture course, then understand that you need to read it, his work in the context from the correct perspective. Spiritual science, as Steiner calls it, is rooted in the work of herbalists and alchemists who place great value of analogies within nature to understand and to have insight. Now, let me share with you this quote: "The farm can be conceived as a kind of independent individuality, a self-contained entity. Every farm ought to aspire to the state of being a self-contained individuality. This state cannot be attained completely, but it needs to be approached." Let me share with you how I have come to see this from the perspective of not just input, but also from losses. And here I want to talk within analogies. In a single cell organism as a simple life form, in the analogy of the farm as a living self-contained organism, here this organism has one and other organs have other semi-permeable membranes. Now, semi-permeable membranes are not designed to keep everything in and leave everything out. It discriminates what comes in and what leaves through the semi-permeable membrane. But its membrane allows it to have integrity. Now, a more complex barrier to consider is the skin. Healthy skin protects animals from a wide range of environmental hazards, and each major opening of this barrier is, of course, cause of concern. Now, if the farm is viewed like any other self-contained organism, well, where's the analogy of a membrane or skin that ensures its integrity? Of course, it's the soil. So out of my experience of working with the soil, I wondered if exposing the soil isn't like breaking a skin or breaching a membrane. Leaving the soil exposed is compromising the integrity on the farm as a living organism. Now, cultivation not only reduces organic matter, it also reduces or even eliminates mycorrhizal activity as well. So there's this recent study, right, by Laura Martinez in Wageningen, and it shows that the fungal threads functions like a filter to hold nutrients. So the presence of arbuscular mycorrhizal fungi in the soil greatly reduce phosphorus and nitrogen losses under high rainfall scenarios. It's a really interesting study, actually. What they did is they took dune sand and they put dune grass in there. And I mean, dune sand, as all of you know, it's pretty sterile. And in one, they played arbuscular mycorrhizal fungi, and the other ones they didn't. And the results were dramatic. But what is important in this study to understand is that they had to put a plant in that dune sand because mycorrhizal fungi need roots to be attached to. So Isn't it safe to conclude that a healthy farm has much of its land covered at all or most of the times? And the best way to ensure integrity is to cover actively used farmland with, say, grass and legumes, cereal, rye, vetch. So it's not a far stretch, by the way, to conclude that animal husbandry that depends so greatly on grasses and legumes needs to be included in the farm as a healthy, living, self-contained organism. But my challenge really was like, okay, so we know that already, and we know that the grasses and the pastures, they can be pretty self-sustainable. But what about our cropland? And we know that we had quite a bit of success, and I worked at the Hudson Valley Farm Up for a number of years, and had the opportunity there to do some experimenting beyond what I was able to do at Roxbury Farm. And we were quite successful planting soybeans directly to a rolled and crimped rye crop. But if we would plant cabbage or sweet corn through that, we know that the nitrogen would just not be sufficient to sustain it. It was really due to the fact that the soybean able to secure its own nitrogen was giving us a relatively good crop. So we wanted to experiment with 100% legume crops. And anyone who has experience with rolling and crimping knows that rolling and crimping legumes can be a challenge. And here we had some dumb luck trying to kill a standing vetch crop. And the only reason for that was because we had too much ground in vetch, and said, well, let's plant some of it in buckwheat. So here, one of the trainees is planting buckwheat directly through a crop of vetch. And lo and behold, the vetch died. Where we just crimped the vetch, it didn't die. I had to crimp it 3 times and still it would come back. So the cutting of the no-till drill allowed us to be able to eliminate the vetch in one pass. And then we planted through this. Here is sweet corn planted directly through vetch. And because this is in the context of the farm hub, we had access to a very fancy no-till transplanter that we actually determined we don't need. We didn't actually need all the bells and whistles that came with a no-till planter. I will talk about that later. But we did have a very important learning year there. First of all, we know that the tillage that we did the year before and the weed control we did there the year before, the bare fallow we practiced the year before, allows us to have a very clean seed bed. And that allowed us to have a relatively clean crop of both corn, broccoli, and cauliflower. The corn, we did actually a side-by-side comparison between conventional organic tillage and regular, and then planting through the vetch. And the yields were about even. The weed pressure was a little bit higher, of course, in the rolled and crimped vetch. One of the things we found was that the water holding capacity, though, of the organic till was much less. Here is a slide taken on the same day of the conventional organic till compared to planting to Austrian winter peas. Now, one thing we learned is that Austrian winter peas do not give enough weed suppression in order to grow a crop. We did an awful lot of hoeing in that crop. Here, planted through vetch, which gives us a little bit better weed control, but I will not deny that we did an awful lot of hoeing there, is cauliflower. And one pleasant discovery we made was that when after harvesting cauliflower, going to the crop, is that the dead leaves on the ground did not smell so bad. And the crew really favored wanting to harvest the cauliflower in the vetch planted crops than in the organic conventional tilled crops, which is an interesting observation. I don't really have anything to say about it except for the fact that the biological activity must have been better and healthier in the no-till crops. And then, of course, we went out there and started digging around, because that's really the proof of the pudding. And while the ground, of course, in the organic tillage crop was powdery, it fell apart, it had no structure. Here is an image of the soil where we did not plow before planting. And there were a lot of wormholes, and there was still a good structural integrity of the soil. But we had a lot of problems to solve with this. This is definitely not something that I wanted to report about, even though the pictures are beautiful. Please go and do this on your own farm, because we knew that the weed control was not sufficient. So the question I asked myself, what about if we mix in some cereal, not too much, and try to get some better weed control? So in 2018, I applied for a SARA grant and was able to receive that, whereby we want to find out if there is such a thing as a correct mix of a certain amount of cereal and a certain amount of vetch that gives you the best weed control without affecting the carbon-nitrogen ratio in too much of a negative way. So there are 27 plots here at the farm, at Filia Farm, and 8 different seed mixes. Already after the winter, what we found so far is that you can see this is what we call a high cereal mix, 80 pounds, and then only 20 pounds. You can see that the ground is not fully covered, and I'll get back to that later. This is not clean ground compared to the farm hub. This was recently an old hayfield that was plowed in 2019. And so a lot of pasture weeds are returning in that mix here. The crop grew well, the Triticale grew up. The idea behind Triticale compared to rye was that maybe we could roll and crimp a week later, which did not happen. Apparently the Triticale was in antithesis about the same time as the rye. So we rolled and crimped June 15. And then you can see here that especially in the lower seed mixes, the 20-pound, 40-pound Triticale, the vetch completely pulled down the Triticale. The previous slide, where the Triticale is nicely standing upright, those were the 80-pound mix. So immediately we already noticed that if you are mixing in some cereal, if you don't mix in enough, the vetch will basically pull it down, and creating a problem with the rolling and crimping, because it will fall in all kinds of directions. And you can see that here too from the other side there, where you can sometimes when you roll and crimp a straight rye crop, it has these beautiful lines in the field. Where there's no lines in the field here, it moves in all direction. So we had to think about how we're going to plant through that. Basically, what we end up rigging together is this transplanter right here. It's a mechanical transplanter. It's not designed for no-till, but have a double disc opener on there and adding some other features to it allowed us to convert it to a no-till planter. Let me tell you a little bit about that. So first of all, we needed to add a coulter before the drive wheel. Now this is a wavy coulter, which ended up not working. We replaced it with a straight coulter, and we need to find out how much space we needed to get between the first bar, diamond toolbar, and the second diamond toolbar, and we ended up determining that it had to be 21 inches after a couple of, when we made them too short. So we had to have clamps custom built to hold the other coulters in place. And we also had to replace, because one of the things about planting conventional equipment, even a corn planter, whatever you're using, utilizing that under no-till, which is not completely no-till because it was tilled the year before, the ground is quite soft. The biggest problem is closing. So we had to change the closing wheels. on this transplanter from having a bevel on the one on the right here to basically being the old-fashioned style closing wheels that are completely straight. That was day for transplanting. We were started the plants in Windstrip 72s. And then we were not able to have enough weight. So one of the things about these no-till planters is that they have a lot of weight. Well, we resolved that by putting a couple of 2x6s on the frame and a couple of cinder blocks. And we added, by adding 300 pounds of weight to the front, we had plenty weight for the coulter to sink into the soil and to slice the ground. The other thing we found is that soil moisture is extremely important for penetration. So being able to, with this very, very dry, being able to irrigate right before planting is crucial. So we did have, when we started planting, we had enough moisture, and then it quickly dried up. And by the time we got the transplanter to work, we realized we had to add more moisture to it in order to get good penetration and good closing. So here is a video that shows you what it ended up looking like.
Yeah, but the Triticale looks like it's all going the same way. Yeah, it helps.
So this is what it looked like afterwards. You can see that I have no access to a no-till drill here. So the vetch, even after rolling and crimping about 3 times, still stayed alive, but it never really seemed to be much of an issue. So as you can see here, when you are using row cleaners and everything else on the regular no-till planters, you are creating an area where weeds could actually invade. So the whole idea was that we wanted to plant this crop as close as possible to the existing mulch. Here's the control plot, as you can see here, and you can see how much vetch still survived. And now this trial is not done yet. We're going to see what the yield difference is going to be between the different seed treatments. And as you can see, we have tremendous weed pressure here. This is a slide taken at the beginning of this week, just to give you an update. And with this, I will conclude my talk.
Thanks so much, Jean-Paul. I have a question here saying, have you had success killing hairy vetch at flowering with flail mowing?
You can absolutely flail mow your hairy vetch and it will kill it. Every time you create very small particles, and we knew that already from mulching, when we mulch by running it through a bale shredder compared to taking it from a square bale, that the amount of time it takes for that mulch to break down is much slower when it is whole and not shredded. Then so that's really the real issue, that I think the weed control is going to be even more severe when you flail mow.
Great. Another question, is there any issue with hairy vetch being invasive? You guys always get it before seed, but if it's very hard to kill, is there some that ends up going to seed?
If there is a rotation whereby you are growing especially winter wheat and you want to harvest that winter wheat, please stay away from hairy vetch. As a vegetable grower, so this is really in the context of a vegetable farm, I have never seen hairy vetch becoming a wheat problem. So far, of all the cover crops that I've used over the years, the only one that has ever been an issue, us weeding it out, that the cultivation equipment couldn't take it out, has been buckwheat. Buckwheat can persist for up to 2 years if you let it go to seed. The hairy vetch going to seed, it is so weak in the beginning that it's relatively easy to cultivate it out. So I have not been too concerned with that.
If anyone else has questions, there's the question and answer tab down at the bottom, and I can read those aloud. Okay, we have another question. Did you drill the oats and peas into the winter mode warm season cover crop? It looked like rows. If so, was it a no-till?
Is there any? Okay, here we go. So the oats and peas, yes, it was no-till drilled directly through the mulch, and it was a no-till drill. What we used was a Great Plains no-till drill, which is not dependent on hydraulic pressure, and it had no problem whatsoever penetrating that crop and get a really wonderful seeding of oats and peas in there.
All right, another question. Can you sell any cover crops?
Yeah, that's a good point. So I think, again, the question is going to be that as a vegetable farmer, I am really not so much in the business of combining grains. We're eliminating these cover crops before they actually set seed. If they set seed, then we made a mistake, like with buckwheat. With hairy vetch, for example, when you're not able to eliminate it in time, that's basically a mistake. So if you let them go to seed, first of all, the amount of time it takes, for example, with rye, brings you right at the end of when you can seed your crotalaria and sorghum. So now we're talking about the end of July already. So it gets a little bit later. Can you do it? Yeah, I think you can. So you could combine it. Is the weed pressure a little bit greater with some of these crops? Yes, absolutely too. For example, your hairy vetch, if that goes to seed and it gets into your wheat, you have a problem. So I feel like this is one of those things that you rather leave that to the experts. And generally speaking, grain growers have generally pretty good rotations. It's the vegetable farmers that need these rotations and have this tremendous loss of organic matter due to the frequent tillage. And of course, I'm talking about the context of organic vegetable grower who do a tremendous amount of tillage. And that's where this really comes out. So I don't say no to this question. I just see it being a bit impractical.
Okay, we have another question. Can you share a little bit about the Roxbury Ag Institute in its current form?
Yeah, thank you for asking that question. So Crystal and I moved here to Johnstown, New York, and with the notion that we'd like to do some more on-farm research and being able to have some more time to write some of these things down. If you're working on a large commercial farm, it's hard to have that time. So right now at Filia Farm, we are doing this research on the no-till, but we're also doing a number of variety trials, as well as some trials that are based on exclusion netting to eliminate cucumber beetles. So we are dedicating more of our time on both doing the actual work in the field and writing about it. So we are not an institute in a traditional form. Maybe institute might be a little bit too big of a word here, except that it made us think about how I want to spend some of the time in the last part of my career and how I want to dedicate that. And one of the most important things that I would like to work on is the fact that climate change is here, and how can we think about crops and systems and procedures that allow farms, especially vegetable farms, to become more resilient. What are some of the answers that we can have for that? Being able to free up a significant chunk of my time to do that is important. Secondly, I am available for on-farm consulting. So I spend about 1/3 of my time doing consulting, 1/3 of my time farming, and 1/3 of my time I'm doing research.
Follow-up question, are you collaborating with any Cornell researchers?
I'm collaborating with Cornell Cooperative Extension. As you know, my wife, Crystal, is an extension agent, a specialist here in New York. And on all the trials that we work with, we are working with Cornell researchers through Crystal and her team, the Eastern New York Cornell Commercial Horticulture Team program. So that's something that we absolutely is our work. I always collaborate informally with anyone at Cornell because it is very stimulating to work with them. But for example, we're in the process of rewriting the crop and harvest manual of Roxbury Farm. And this is done in great collaboration, again, with Cornell Cooperative Extension to make sure that we can fact check this and make this available as an organic grower manual.